Hello guys, so I would like us to look at longitudes and latitudes. Now we start off with definitions of small circles and the great circle. So assuming we have our sphere like this, and we have this circle which passes exactly in the middle of the sphere, dividing NS into two equal parts and having a radius capital R, that is called a great circle. And any other circle that is perpendicular to this line NS, let's say if we have this circle and any other circle, we could have another circle over here, we could have another circle over there having a radius which is smaller than this capital R. That is what we call a small circle. Okay, they have a radius R which is less than this radius of the circle in the center. Now, note that every great circle bisects a sphere into two hemispheres. So this is one of the great circles. And also, if we have another sphere here, just to show you the other great circles, all the circles that are passing through N and S actually divide this sphere into two hemispheres. They are also called great circles. So we have this great circles passing through NS, and then we have this other great circle which divides NS into two equal parts, all of them having radius capital R. Okay, next thing, the equator and the Greenwich meridian. Now, the great circle that was passing, so let's assume this sphere of us represents the Earth, then NS, that is basically the Earth's axis, then 0, this is the center of the Earth. So the circle that passes at the center and divides the Earth's axis into two parts, that's our equator, okay? And then the latitude, this basically are the small circles that are perpendicular to NS or parallel to the equator. So like this is the latitude, this is the equator, and this is the Earth's axis. Then the meridian is basically half of a great circle which runs from N to S. Okay, so it's also part of a great circle, but it runs from N to S. And we specifically have the prime meridian, also called the Greenwich meridian. This is a meridian which passes through a village in London, which is called Greenwich, okay? And it's at 0 degrees. So like that's the prime meridian. Now, longitudes. The angle measured east or west from the prime meridian is what we call the longitude. Okay, angle that is measured either east or west from the prime meridian. So if this is our prime meridian, then the angle that is measured either west or east from the prime meridian, that's what we call our longitude, east or west. All the points on the same meridian have the same longitude. So if we were to like really consider this meridian here, all the points here will obviously have the same longitude. So if this is, let's say 0 degrees, that's 0 degrees. If we were to consider another meridian, let's say 30 degrees, then the points, if we were to consider another meridian here, let's say this is now 30 degrees west, this point and this point will obviously have the same longitude. Okay, next, an angle of latitude. So we already looked at latitude and we said it's the small circle that is perpendicular to the Earth's axis NS. Now, how do we get an angle of latitude? So let's take up our sphere like this. We have points A, E, and B, which lie on the same longitude. So as we can see, the longitude on the eastern side here, whatever it is, A, E, and B all lie on it. Now, the angles of latitude, as we can see here, the latitude of A, if this is the center, if the center of this sphere is OE, then the latitude of A is 40 degrees north. And the latitude of B, as we can see here, is 55 degrees south. Now, since A and B are on opposite sides of the equator being the center here, the angle AOB is obviously 40 plus 55 degrees. If you want to get angle AOB, it is 40 plus 55 degrees. And this is what we also call the latitude difference. So if you're getting the latitude difference of two angles which are on the opposite sides of the equator, one is on the north, the other one is on the south, then we get the angle by adding them. Now, latitude difference for, let's say we want to get latitude difference for an angle which is 40 degrees north and another one which is 10 degrees north. So let's say we have 40 degrees north, which is that one, and then we have another one over here, which is 10 degrees north. And then we want to get, so we have C, let's call it C. And then we want to get the latitude difference. Now, the latitude difference for angles which are on the same side of the equator. This is north and this is north also. So the latitude difference will be given by subtracting. Note that if they are on the same side, north-north, you get the latitude difference by subtracting. If they are on the same side, you get the latitude difference by adding. So another example here, the latitude difference of, let's say, B, which is on the northern side, and C, which also is on the northern side. Since they are both in the north and the north side, then we will get the latitude difference. This is supposed to be by subtraction, since they are both in the north and north side. So this will be 55 minus 10, and that will give us 45 degrees. And the same applies to the longitude. If we have angles on the same side, both being on the eastern side, then we get the difference by subtracting. And if we have the angles, one being on the eastern side, another one being on the western side, then the latitude difference is gotten by, the longitude difference is gotten by adding. Okay, next, let's look at radius of small and great circles. Now, if we have our sphere like this, then this is basically a small radius of some latitude. Then if this is the center of our circle, then this is the radius R of the equator. So, and this, since this is a meridian, the radius is also capital R. Let's take up this angle to be theta. If this is theta, it is alternating to this one, so this is also theta. Now, if we were to get the value of cos theta from SOHCAHTOA, it's adjacent of hypotenuse, where our adjacent is the small r. This is the radius of some small latitude here. All this divided by the hypotenuse, which is capital R. Okay, which is the radius of some longitude here. So cos theta is equal to R over R, where R is the radius of the small circle, some latitude, and R capital is the radius of the great circle. So the relationship is, if we want to get R, the radius of a small circle, then it is equivalent to R, the radius of a great circle cos theta, and most of the time the radius of the big circle, which basically here we are referring to Earth, will always be given. So this is the relationship for evaluating the radius of a small circle. Okay, next, position of a place on the surface of the Earth. Now, in order for us to get the position of a place on the surface of the Earth, then it is important for us to determine both its latitude and longitude. So we first of all start by writing the value of its latitude and then writing the value of its longitude. So for example, here we have A, B, and C. So this should be our C here. Now, if you look at a point A, B, and C, they all lie in the same meridian, which is 30 degrees west. They all lie in the same meridian. So what we are interested in is, first of all, getting to know. So let's say like the point A over here, as we can see, it is 80 degrees north. And we start with evaluating for the latitude. So this is 80 degrees north for the latitude. And then the longitude, as we've seen, they are all on 30 degrees west. Let's go to B. Looking at point B here, as we can see, it's on the 10 degrees north. So 10 degrees north. And then clearly it is on 30 degrees. The longitude is 30 degrees west. And finally, point C, so we can clearly see this is 0. So it's like on the equator. So it's 0 degrees, okay? And then on the longitude is 30 degrees west. So in order for us to give the position of a place on Earth, then it's important for us to write both the latitude and the longitude of that particular position. Okay. Next. So distance between 2 points along great circles. Now, in order for us to get the distance between 2 points along great circles, we've already looked at 2 great circles. We've already looked at the equator as a great circle, and we've also looked at the meridians also, which also divide the Earth's surface into 2 hemispheres. So the distance between 2 points on the same circle is the length of the arc. We take up a circle like this, and then we want to find, so let's say we take up, this is, let's say a meridian on this side, and then we want to find the distance PQ. Now, how are we going to get the distance PQ? The distance PQ is basically the area all round. So from 0 to P, P to Q, Q to 0. So basically that's like the perimeter of this particular arc here. So this will be given by the length of the arc, which is theta degrees, that is the angle that is subtended in the middle, over 360 degrees times 2 pi r, where r is the radius of this particular circle over here. Now, this will give us our answer in kilometers. Now, what if we want to get our answer in nautical miles? Now, in order for us to get our answer in nautical miles, then it is important for us to know the conversion. Now, 1 minute of an arc is equal to 1 nautical mile, or 1 degrees of an arc is equal to 60 nautical mile. And also 1 nautical mile is approximately equal to 1.85 kilometer. So we can use either of this depending on what exactly we've been given to get the distance in nautical miles. So remember, we're evaluating distance along great circles. Okay, fine. So now let's start by looking at, maybe let's say, the distance along the equator. So let's assume that we are looking at, because equator is one of our great circles. So distance along the equator, find the distance between 2 points. So as you can see, it's along the equator, because as you can see here, we have 0 degrees, 0 degrees, okay? So find the distance between 2 points. This is point P, 0 degrees, 30 degrees west, and Q, 0 degrees, 20 degrees east. So as you can see, this is west and this is east in nautical miles and then in kilometers. Now let's come back. Okay, distance in nautical miles. So the distance in nautical miles, actually the formula for getting the distance in nautical miles is given by, so as we can see here, 1 degrees of arc, 1 degrees of the arc is equal to 60 nautical miles. Now, if we were to, how many degrees do we have here? So if we were to have a rough sketch of this, we have P being 30 degrees west. So let's just have like a rough sketch. Then this is like the center, 0. So let's have, we have this, then we have this. Okay, so P, let's say P is somewhere here. Okay, so it's 30 degrees west, so 30 degrees. And then we have our Q, which is 20 degrees east. So let's say we have this as our Q over here, 20 degrees east. So 20 degrees east, east, west. Okay, so now that is the length that we want. So from the formula here, we can clearly see that 1 degrees of arc is equal to 60 nautical mile. Now, how many degrees do we have here? We have 30, 20, they're on opposite sides. So clearly we have 60 degrees. So 30 degrees, sorry, plus 20 degrees is equal to 50 degrees. So if 1 degrees of arc is equal to 60 nautical miles, then what about 50 degrees of arc? 50 degrees will be 50 times 60, and this will give us 3,000 nautical miles. So that's how we get the distance in nautical miles. Now, evaluating the distance in kilometers. Evaluating the distance in kilometers. So basically what you want to get is the length of the arc. And how do we get the length of the arc? Here is the formula. The length of the arc is given by theta. So the theta over 360, the angle subtended in the center, times 2 pi r. So we will have theta over 360 times 2 pi r. And our r here, because it's a great circle, then it's obviously capital R. I hope we can be able to relate that, because the distance along the equator is obviously capital R. So the R here is actually capital R. So our theta will be 50 degrees over 360 degrees times 2 pi times R. We've been given our R as 6370 kilometers. And if we evaluate this, we get 5,560 kilometers. So that's how we get the distance along the equator. Okay, so the first point, if we are looking for it in nautical miles, remember 1 degrees of an arc is equal to 60 nautical miles. So if you have the angle so that you can be able to get the degrees of the arc, then you can be able to get the distance in nautical miles. And then if you're evaluating the distance in kilometers, then you remember this formula. And since we were evaluating along the equator has capital R because it has the big radius. Okay, still under distance between great circles, let's look at the meridians, because the meridians are also great circles. So distance between two places on the same meridian. Now let's say we're being told to calculate the distance between two places. A is 80 degrees north, 30 degrees west, and B is 10 degrees north, 30 degrees west. So we can clearly see that both of them are on the 30 degrees west. Are we together? So both of them are on the same meridian, 30 degrees west, 30 degrees west. Now, how do we get the distance? So first of all, we start by getting the distance in nautical miles. And what did he say? 1 degrees of an arc is equal to 60 nautical miles. So how many degrees do we have here? So they are both like, if we were to have a rough sketch of this so that we can clearly see how exactly it is, they are both, so I have this as our center, they are both on the 30. This is our 30 degrees west. So 30 degrees west. This is 30 degrees west. Then we have one angle being 80 degrees north. So let's have this as our center. Then let's have maybe 80 degrees north is here. And then we have the other 10 degrees north. So let's have maybe 10 degrees north being there. Okay, fine. So like if these are the points that we have, so like what's the angle between them? Since they are both on north, then to get the difference, we are going to subtract. So it will be 80 degrees minus 10 degrees, and that will give us 70 degrees. Since 1 degrees of the arc is equal to 60 nautical miles, then we will be getting how 70 degrees will give us what in nautical miles. So we'll have 70 times 60 nautical miles divided by 1. And if we evaluate that, we will get 4,200 nautical miles. Okay? Then now on to the distance in kilometers. Remember the formula for the distance in kilometers? Theta over 360 times 2 pi r. So let's first of all come and write it here. So B, to get the distance in kilometers, theta over 360 times 2 pi r. This is what is going to give us the distance in kilometer. Now, what is our theta? We already found out that the difference is 70 over 360 times 2 pi r. Okay, so this is times 2 times pi times r, where r is the radius of the earth. So our r has been given as 6370. Our r has been given as 6370. If we evaluate that correctly, we will get our answer. Our answer is equal to 7783 kilometer. Okay, so that's how we go about getting the distance of great circles, the distance between 2 points of great circles. Because if they are great circles, then we basically know the radius is capital R. If they're great circles, then you obviously know. So all the time when you'll be replacing this R, the radius will be the capital R, because it will be the radius of some great circle, either equator or the meridian. So note that. Okay, fine. So the next thing, we look at the distance between places along circle of latitudes or along small circles. So let's say we have this particular distance xy along along the latitude. So in order for us to evaluate the distance xy is given by the angle subtended by that distance, which is x degrees over 360 degrees times 2 pi r. Okay, where r, the small r now, because now we are evaluating small circle, we looked at this initially and we said r is equal to capital R cos theta. So we will replace the value of this because it's small circle. So this r is the small r. And we will replace this small r with r cos theta, so that our new formula is x degrees over 360 degrees multiplied with 2 pi capital R cos theta. So instead of the small r, we have r cos theta, where r is basically the radius of the earth. And then the distance in nautical miles will be given by longitude difference times 60 degrees times cos theta, where theta is the angle of latitude. Note, where theta is the angle of latitude, because we are evaluating along a circle of latitude. Okay, fine. Let's take up an example. Calculate the distance between 2 points. So calculate the distance between 2 points. So the point X, 40 degrees north, 30 degrees west, and the point Y, 40 degrees north, 20 degrees east. So clearly we can see they are both on the 40 degrees north. So they are clearly along the same latitude of 40 degrees north. Now, how do we get the distance in latitude? How do we get the distance in nautical miles? Here is the formula. It's longitude difference times 60 times cos theta, where we've defined theta here as the angle angle of latitude. Okay, so coming to evaluate that in nautical miles, we are going to have, so longitude difference. So longitude difference times 60 times cos theta. That will give us our answer in nautical miles. Now, what is the longitude difference? What is the longitude difference? We have 30 degrees west, 20 degrees east. They are on different sides. So that will be 30 degrees plus 20 degrees we add, times 60 times cos of theta, where theta is basically our 40 degrees, because as we've said here, theta is the angle of latitude. So evaluating this, we will get 2,298 nautical miles. And what of the distance in kilometers? So going back to the formula, so part B, in kilometer, we've said that the distance in kilometers is given by x degrees over 30 degrees times 2 pi r cos of theta. So what is our x? We found that the difference is 30 plus 20, which gave us 50 degrees over 360 times 2 pi. And what is our r? Our r has been given as 6370. We were initially given r as 6370. So let me just write it here. It's the same one that we will use. R is 6370 kilometers. So that is r, radius of Earth. So times 6370 times cos of theta. Okay, because theta is the angle of the latitude. So evaluating this, we will get this to be equal to 4,259 kilometers. Okay. Okay, so after that, the next thing, so we've already looked at distance along great circles, that is along the equator and the meridians, and also along now the latitudes. So the next thing that I would want us to look at now is time and longitude. Now, the difference in longitude of 1 degree is equal to 4 minutes. That one we should remember when we're evaluating. We also should know that the Earth rotates from west to east. Okay, hence the sun rises later at a more westerly place. Okay, similarly, the sun sets earlier in the more easterly place. Okay, so for example, here we're being told the longitude of Nairobi in Kenya and Punjab in India are 38 degrees east and 81 degrees east respectively. What would be the time in Punjab if it is known in Nairobi? Now we know that the time difference from this formula, the time difference in longitude of 1 degree gives us 4 minutes. Okay, so now what is the difference in longitude between Nairobi and Punjab? They are all on the eastern side. Okay, so the longitude difference will be given by 81 minus 38. So longitude difference will be 81 minus 38, and that will give us 43 degrees. We know that 1 degree is equal to 4 minutes. 1 degree is equal to 4 minutes. So what of a longitude difference of 43 degrees? So evaluating this is 43 times 4 minutes, and this will give us 172 minutes. If we convert this 172 minutes into hours, so this will give us, so divide by 60, that will give us 2 hours, 52 minutes. Now, we are being told that it is noon in Nairobi? What would be the time in Punjab if it is known in Nairobi? Now, from the longitudes, we can clearly see that Punjab is at 81 degrees, meaning it is more on the eastern side than Nairobi. So obviously, like if it's on the eastern side of of Nairobi, then the time will be 2 hours 52 minutes ahead. So let's say, so if we have 12 in Nairobi, then 2 hours 52 minutes. So that will give 52 and that will give 14. Okay, so 14:52. So this is basically 2:52 p.m. because it is more on the eastern side. Let's take up another example. P and Q are two places on the equator with longitudes 4 degrees and 9 degrees respectively. If it is 20-30 hours at Q, find the time at P. Okay, so it is 20-30 hours at Q. So P and Q are two places on the equator with the longitudes. So as we can see, this is 4 degrees. So the longitude difference is, since they are on both sides, one is on the east, one is on the west, it will be 4 plus 9. So the longitude difference will give us 13 degrees. Now we know that 1 degree is equal to 4 minutes. So what is 13 degrees? 13 degrees will be 13 times 4, and that will give us 52 minutes. Now we're being told it is 20-30 hours in Q. So let's see, Q is the one which is on the west. Okay, so Q is on the west, and then P is the one which is on the eastern side. So this is on the east. So basically the easterly, the one that is more easterly will always be ahead in time. So if it is 20-30 in Q, then it means 20-30 in Q, then it means in a P, it will be 52 minutes ahead. And adding that, we'll get that in P, it will be 21-22 hours, which is basically 9:22 p.m. So that's it. The relationship between time and longitude. Next, I would like us to look at speed in knots and kilometers per hour. Speed in knots and kilometers per hour. Now we should know that 1 knot is the same as just 1 nautical mile per hour. So 1 knot is equal to 1.85 kilometer per hour. So if we already know that relationship, we can take up a question here and see how exactly to go about it. So we're being told a ship sails due east from an island, 48.7 degrees north, 42 degrees east to another island B. Okay. The average speed of the ship is 27 knots. So we've been given the speed of the ship as 27 knots. And it takes 22 hours, this is time, to reach B. So it's going at this speed and it takes 22 hours to reach point B. Find the distance between the two islands A and B in nautical miles and then in kilometers. So let's first of all start to find the distance in nautical miles. Now, how do we get distance? Distance is equal to speed times time. So we've been told here that the speed is 27 knots and the time is 22 hours. So we will have 27 knots times 22 hours. So what will be the distance in nautical miles? If you multiply this, you'll get that the distance is 594 nautical miles. Now the distance in kilometers. So in kilometers, we know from our previous work that 1 nautical mile is equal to 1.853 kilometer. So if we have 594 nautical miles, then what will this be in kilometers? So you just cross multiply. That will be 594 times 1.853. And that will give us a distance of 1100.682 kilometers. Okay, Then the next question is asking for the speed of the ship in kilometer per hour. Now we already have the distance in kilometer and we already have the time it took. So this is the distance and we already have the time, 22 hours that it took to reach B. So what is the speed of the ship in kilometer per hour? Now from this formula here, speed is equal to distance over time. So we will have 1100.682 kilometers over time that it took, which is 22 hours. And what will this give? This will give us 50.03 kilometers per hour. Okay, then finally, the last question is the position of island B. The position of island B. Now, if we want to get the position of island B, so first of all, if the longitude difference of, let's say, A and B, let's say the longitude difference of A and B is some theta, then we already have the distance in nautical miles. So since we already have the distance, we know that the distance in nautical miles, so distance in nautical miles from our previous example is equal to theta, where theta here basically is the longitude difference between point A and B times 60 times cos. So time cos of, we already have here our, we already have here 48.7 degrees as our latitude. So cos of 48.7 degrees. So distance in nautical miles, we've already gotten the distance to be equal to 594 nautical miles. So 594 nautical miles is equal to, so we don't know this theta here. We don't know the longitude difference between A and B. So that's what we want to get. So in order for us to get that, we'll divide this side by 60 times cos of 48.7 degrees. And that gives us theta. Theta is equal to, so if you evaluate that correctly, you will get 15 degrees. Now, since we are being told that the ship sailed due east from 42 degrees east, it sailed due east, then it means that add 15 degrees, and this is going to give us 42 plus 15, 57 degrees east. Okay, 57 degrees east, which is basically the position of island B. So the position of island B, we say that the position is given by latitude, then longitude. So the latitude is 48.7 degrees north, and then the longitude, we've gotten it as 57 degrees east, and that's it. Okay, so basically that's it for latitudes and longitudes.